Hello there, this is just the final part of my look at the improvements I've made to BM's cassette interface over the past year. If we take a look at the help display for a patched copy of BM, we can see that I've added 3 new command line arguments, and these are here to support the automated testing functionality. So we have tape test, which takes an integer, which is a bit mask of these 3 values. So we've got 1, 2 and 4, so bit 0, bit 1 and bit 2, which do different things, and they can obviously be used in combination if you OR together or add together these values to produce an integer to feed to tape test. A value of 1, so if bit 0 is set, that means that the emulator will exit if there's an end of file condition. Now, an end of file condition has nothing to do with the Acorn cassette filing system. It refers to tape images loaded into BM. So if you have a UEF file and the read head, if you like, the read pointer hits the end of that UEF file, then you will get an EOF condition, and if tape test bit 0 is set, then it will quit out on that EOF condition. Similarly, 2 will cause it to quit on error. Bit 1 will cause it to quit on error. But those errors, again, are nothing to do with the cassette filing system. That is an internal BM tape error, which would be something like a malformed UEF file. So that's the one that's used for making the emulator quit out with a particular code on if there's a malformed UEF file. And finally, we have cat at start, which is on bit 2, value 4. That one will do a tape catalog, will run a tape catalog on startup. When it runs, it will catalog whatever tape is loaded, and that one, it does the same thing, exactly the same thing as the catalog tape option in the tape menu. This here, catalog tape, which is grayed out by default, but it's exactly the same code as that, except it prints it to standard out rather than popping up a UI window, because that makes it possible then for the unit tests to be able to check the results if it's printed to standard out. So we can demonstrate some of this. If we use the tape option to load a UEF here, and then we use tape test 5, which will be cat at start and quit on EOF. Now, if you use these 2 in combination, cataloging the tape, actually, when it reaches the end of the tape catalog, it will cause an EOF condition. So that tape test 5 should catalog the tape to standard out and then quit immediately afterwards. So we'll just demonstrate that working. So there we are, there's the tape catalog, and as you can see, each line is prepended with this tape test colon, which makes it possible for the test scripts to extract the relevant lines and check that they are what they should be. Just go back to this. So that's the tape test. That's the tape test switch. Record will begin, as it says, begin recording to tape at BM startup. That one is necessary for checking saving to tape, as is a tape save, and that means that when the emulator exits, it will save whatever tape it's been writing to will be saved out to a file, and the format of that file is set by the file extension. I didn't start messing around having multiple tape save options for different file types. I thought it'd be fine just to have the one and a single file name there that you can save out using. So that's these 3 new command line options I added in order to support the unit testing. There's one other thing we can just look at here, which is if we start it in the debugger and look at the help display, I also added a single debugger command, which is this bxn. This is very important. This will shut down the emulator if a particular breakpoint is hit, and it will do so. It will generate a particular exit code, a predictable exit code for a particular breakpoint number. So you can set up different breakpoints. If a game, I spent quite a lot of time trying to analyze games and find their entry points, the protected games that are loaded from tape. I found as many of their entry points as I could. So you can set breakpoints on those entry points, and that gives you a win condition for the test. Then you can see if a game has loaded successfully if that breakpoint is hit. Similarly, you can set breakpoints on the code within the operating system that produces messages like data ? Rewind tape. You can set breakpoints on those routines in the operating system, and you've got a way of catching operating system cassette filing system errors. And a lot of games with custom loaders have their own error routines, custom error routines within the custom loaders, and if you can find them, you can set breakpoints on those as well, and then you've got failure conditions failure conditions for the tests. So that's the bx command, which is the other thing that I added to support the tests in the emulator. Now we'll move on to actually running these automated tests, and I'll provide a bit of commentary on them as they go. On the left here, we're going to see errors from BM, and on the right, we're going to run the automated test script, and we're going to run it fully, although we will have to speed up part of it. So it's started running tests now, and you will, as I say, you'll see errors appearing on the left. There won't be any at first, but they'll start to pick up as we hammer the file formats a bit. And then on the right, it's started with the simple tests. It's moving through those. It's just checking it can load data. It can load some basic file types. It's tested the fast tape mode. It's testing that it can load a CSW that doesn't contain any data, because they had to make a decision about whether that was allowed or not. 300 border, so it's just going to move through these simple synthetic tests. There's a check catalog there. It loads that's the thing that uses the cat on start, and then it's moved into checking that it can load data from all the different UEF chunk types. Now it's going to go through a long check of all the different UEF metadata chunk types it supports. Now you'll notice that one of the tests there has been skipped, and there'll be more. I think currently there are 10 tests maybe that get skipped. Those are tests with which they're all UEF specific tests that will test that test UEF metadata chunks. Not all of the metadata chunks have been fully validated, so BM isn't compliant with those tests yet. The loads of those UEF files will succeed when they should fail, because it's not fully validating these obscure metadata chunk types. So those tests are currently skipped. There's a variable within the test script which you can switch on or off to determine whether those tests are skipped or not. I just switched them off. Obviously, ideally at some point in the future, BM would be brought into compliance with those tests. But for now, I just disabled them, and they're not run. It's not. I mean, it probably sounds like that's cheating, but it's not really a big deal, because nothing is done with those chunks. I think in order to support a lot of the metadata chunks, you'd need a big user interface overhaul. You'd need an actual separate tape window, like BBEM for Windows has. That actually has a separate tape window that sort of shows the chunks. You'd need something like that for BM, I think, in order to support many of those UEF, meaningfully support many of those UEF metadata types. So now it's testing the Tibet file. It's checking all the different, it's trying all the nooks and crannies to see if it can find something that violates the specification. Yeah, and you can see that there are errors now accumulating in the left window, because it's hitting all of these checks in the Tibet loader. We've moved on to tape save, so now it's writing files out, and it will also do these save UEF, load UEF things, where it can save out a file and then load that file back in again. So that exercises both the saving and loading. And then once these are done, we will be onto the actual back in the day tapes, the actual protected games, starting with the ones from the BeebJet set. Here we go, yeah, so Arcadians first. Let's just speed this up because it will take a long time otherwise. Just quickly go through the list of protected games which are tested here. So we've got Arcadians, A Tick Attack, Caveman Capers, Dune Rider, Way of the Exploding Fist, Fortress, Frack, Jet Set Willy, Joust, Missile Control, Nightshade there with the famous Kevin Edwards protection system, Pro Boxing Simulator. Now that one I let the demo mode play out for a little while, because it's possible for the protection system to actually fail during gameplay, so we let the demo mode play just to check that for a little while. Star Drifter, Starquake, Swarm. We've got the music system. That one has an interesting loader which I need to disassemble to figure out what it's doing. Uridium, Psychastria there. We've got Estra, which is loaded twice because it's checking to see. That's a test for working around the old make UEF parity switching bug. So it loads Estra twice with versions UEFs made from two different versions of make UEF 1.9 and 2.4 to check that it works around the switched parity bug correctly. Then we've got some those were all from Chris Evans's Beebjit set. Then we've got some that I added in from Stairway to Hell. So Saberwolf, Alienate, Chipbuster, Jetpack, The Hacker, Nightlaw, and Video's Revenge. Then it loads Ultron 5 times because Ultron has a 300 baud section, and so that tests various different ways of loading 300 baud tapes. So it loads Ultron 5 times at the end there. We just move on to the so-called Hoglet histogram or TDRE timing tests. So the Hoglet histogram tests, assuming you start with an empty transmit pipeline, an empty write pipeline in the ACIA, and you then write a byte of data to the transmit data register. After a short while, that byte that you wrote will be copied into the output pipeline, so it'll be moved into the shift register, and the TDRE bit in the status register will be updated to reflect the fact that the data register, the transmit data register, has now become empty again. So the question is, how long is that delay between you writing the byte of data to the transmit data register and the bit, the TDRE bit, saying that that register is now empty again? And it turns out that it's, if you do this on hardware, it's between half a bit and 1.5 bits, and that's true regardless of the baud rate. So we're just running, this is on patched version of BM, so this is what the TOH patched BM does now. In the top right there you can see the that's what you get on hardware. So all of the values are between 400 microseconds, which is about half a bit, and 1300 microseconds, and I think the median is 832 microseconds. And that's what the patched version of BM does, and as you can see, it's the range is the same as what it is on hardware there in the top right. Then we do this again at 300 baud, although we speed this up enormously because it takes ages. And then once that's finished, again, this is what it looks like on hardware in the top right. And everything's multiplied by 4, so it's between about 1500 microseconds and 5000 microseconds now. It's just 4 times the previous lot because it's at 300 baud. So it's still 0.5 bits to 1.5 bits, but the bits are 4 times as long. No other emulator passes that test. Now let's move on to looking at the improvements in the tape signal generation. If we listen to the tape signal generation on an unpatched version of BM, it sounds like this. To me, sounds more like a poorly tuned shortwave radio. In the patched version, it sounds like this. Which, if you're familiar with such things, you will realise is much closer to what an actual Beeb produces. But you don't need to take my word for that, because you can actually take the tape signal generation from the emulator and feed the result into an actual BBC Micro, and it will load it just fine, as this video shows. You can also do this while you're saving rather than loading. So if you enable record and append to tape, and you do a save from the emulator, you can load that saved output tape signal directly into a Beeb as well, and that also works. So there you are, there's the remaining improvements that I've made to BM over the past year. Thank you.